multiplication of algebraic fractions. Ooh, I see part of the problem. This thing picks up that one light up there. And that makes it hard to see this board. Maybe we can put your paper up there. Can't turn it off because then this one turns off. Okay, so revisiting multiplication of fractions. What does it equal? A half times a third is 1/6. Straight across the top, straight across the bottom. We must be able to do this without fail. Without fail, every single time, period. We have to, this is something we just have to know. And if we can't do this, we have to go back, we have to relearn that. Because algebraic fractions are going to be things like this. A divided by B multiplied by C divided by D. So in this case here, it's numerator times numerator. And denominator times denominator. I think this is a property. The multiplication fractions property. That's what this is right here. So the multiplication fractions, abbreviate multiplication and property. That's it. All real numbers except these will never be 0 because fractions can't have a denominator of 0. So this works for everything as long as B and D are not 0. And the way they write this is they say all real, so this double barred R, it means real numbers. All real numbers A and C. And then they use like a semicolon, B and D may not be equal to 0. So this just says we can't have fractions with 0 as the denominator. That's what it means. But when we write properties and theorems and things like that, we get into this idea here, where we say what the variables can actually be, what numbers work. So, what if we represented this multiplication using a rectangle? And if we did that, and we said that this rectangle was just a 1 by 1. So this is one across, and 1 high. What's the area of that square or rectangle? It's 1 square, 1 times 1. That's the area. So then if we did this, if we took that half and we broke it up like this, so here we have 1/2. So we're just going to go a halfway up. And then the third, we came across, here's 1/3 coming that far. And then if we did some shading, and we shaded our 1/2, if I shade half of that box, there's going to be a half. And then if I shade 1/3 of the box, or put a different color, I'll go the other way. Where they overlap is our answer. You see, another way of reading this would be 1/2 of 1/3. So I start with 1, I take a third, and then I take half of it. So here's that third, I take half of that. This is my answer right here. 1 out of 6 total. So with this idea, we can represent this also. And that's what a lot of this work is when it comes to being able to make pictures of what we're doing. So we're going to do this one. We're going to take and multiply L over 4 times W over 3. L over 4 W over 3. So there's several different ways to look at it. We could look at it just using the property. Numerator times numerator. Denominator times denominator. There it is. That's the most straightforward, simple way to look at it. But if we were going to draw a representation, a picture of it, we take a box. And it doesn't matter what it looks like, as long as it's a rectangle. It can be a square, it can be a rectangle, whatever. And if you look, what we did here, we used the denominator to figure out how many rows to make out of this. So if I use that denominator, how many rows should I have going across my box? You should have 4 of them, right? So that's going to be this way. But we're going to shade one of them, but here we're going to shade L of them, and we don't know what L is. So what we do is we just look up and down here, and we say, okay, well, somewhere across here is going to be where we're going to call L. That's going to be our cutoff. So how many L's do we have here? We have 1. So it probably makes sense to just do it right here and say that this is 1 L. Then maybe that's 2 L, that's 3 L's. And then if you have 4 L's, then you would have 4 L over 4, which is 1 whole L. So actually this represents L right here, and that line is one of the 4 L's. Let's go the other direction. The W's get divided up into 3 parts. So this is going to be W out of L, or out of 3, but it's just one of them. So the whole thing, all the way across here, is like W. That's the width. And we're going to take one of these 3. So this right here is going to be W divided by 3. This would be like 2W divided by 3. This over here would be 3W divided by 3. If you do 3W divided by 3, again, that's 1 whole W. So when we went this direction, that whole thing, that's the length. And we're just taking 1/4 of the length, but we're writing 1/4 of it like this. Do you remember earlier on in the year, we did things like this? These are the same as one another. And it can also be written as 1 times L over 4. They all mean the same thing. L divided into 4 parts. So then we come along here and we say, well, there's our shading of the 1/4 of the L. And then here's our shading of the 1/3 of the width. And where they overlap is right here. So this is 1 part of how many total? What's the total number of parts? It's 12. And look what we have. We have 1 part of the W and the L out of 12 parts. There's the representation of it. This is hard to picture, but it can also be helpful at times. You do it more and more, it becomes more helpful. There's another thing in this lesson that they want us to remember. from the past. There's the multiplication property, multiplication of fractions property. And then there's one called the equal fractions. This is not so good anymore. The garbage group. A whole lot better, but. So equal fractions property. What's another fraction equal to 3/5? 6/10. Multiply the top and the bottom by the same number, right? We've done that a lot. So here's what the equal fractions property says. A over B, any fraction, is equal to another fraction if we use the same number to multiply the top and the bottom. So that's where K comes in. They use K quite a bit in algebra, talking about a number that gets used over and over, K, a constant number, and then they, constant is spelled with C, but still. They use K. And this works as long as K is not equal to what? 0, because then you'll get 0 in the denominator, and that doesn't work. You can't ever have it.
So should K not be 1, 2?
Well, it could be 1, because A over B is still equal to A over B. Like this, if you multiply by 1, you just have the same thing, and they're still equal. Usually we use a number other than that, though, right? Yeah. So that doesn't mean we can't use it. And they want us to keep this in mind, because part of this work in this lesson is going to be not only multiplying fractions, but simplifying algebraic fractions. So they give one here, they give an example, 3. And they want us to simplify. And it's 112 times A times B over 7A. So they want us to be able to simplify this thing. And if we keep this in mind, that fractions can be written with factors, numbers that multiply together to make things, then we can simplify. And I do a lot of that with you. Like when we were multiplying through, like if you had something like, 1/2 x plus 1/3, and I said, well, multiply through by 6. And then when you do that, the 6 over the 2 becomes a 3. That's simplifying. So we turn this into 6 times 1 over 2. And then we turn this into 6 times 1 over 3. The 6 over 3 gets simplified into 2. That idea gets used here a lot. So we'll get better at this. So in order to simplify, we need to have a 7 be used in multiplication to make the 112. So can you multiply 7 times anything to get 112? That's what we're trying to do here. So change 112 into 7 times some number, and then we're times A and we're times B, and then we're 7 times A on the bottom.
7 times 16.
7 times 16 is 112. Good. And then 7 divided by 7 is equal to 1. So that simplifies. And A divided by A is equal to 1. Any number divided by itself. So then when we look at this, we're left with 16 times B and just 1 on the bottom. So this simplifies to become 16B. So then in the spirit of simplifying before we multiply, the last thing that they give us is this. And that one they want us to multiply it out. But simplify before we multiply it. So because it's multiplication, if you want to make it more clear to you, you can change all of this in terms of the order that the terms are being multiplied. That's 4 times x, that's 3 times y. So you could write 4 times 3. Commutative property allows you to change the order. Times x times y. And then you can do the same thing on the bottom. You can bring all of your integers together, 27 times 2. And then you've got an x squared. I'll put that underneath x. And then the y. We just change the order of everything if we want. So now if you just look at the integers, can you simplify any of that? Is there anything on the top and the bottom that are divisible by the same value? 2 and 4.
3 and 27.
Okay, so 2 and 4 is going to turn into what?
1 and 2.
A 1 and a 2. And then the 3 and 27, you said?
3 and 9.
Yeah, so this is 3 times 9, isn't it?
1 and 9.
So 9 and 1. Divide both of them by 3. Now how about this? Here, you want to look at x squared as x multiplied by x.
2x.
That's not 2 times x. That's x times x.
Can you get rid of the bottom?
Yeah, let's do the easy part. Y divided by y is 1, isn't it? So now how do you got an x and you have x times x.
Can you just get rid of one of it? Just on the bottom and then just do it.
Yeah, you get rid of one of these and one of those. Think of it like this. What if I had a number like 7 over 7 times 7? 7 is the same as 7 times 1. So now I can just cancel out those 2 7s. And you get 1 over the 7. So if I cancel out one of these x's, I can just cross out the exponent and leave that one to the first power. That's really what we're doing. We're crossing out this one. So then we take the whole mess and we look at it. We've got 2 times 1 and 1 and 1. This is just 2 on the top. And then on the bottom we have 9 times 1, which is 1, times x, which is 9x. So 2 over 9x. $40 or $30?
40 today.
40 today, right?
Or do it on Monday.
45 today. Holy schmoly, we're here forever. We have 17 minutes. Why don't you go grab your whiteboard? Grab your whiteboards. I'm gonna erase this. Simplify that one.
Simplification.
Is it just 3, right? But here you divide by 5, but you divide by, you don't divide by 5. B divided by B, and the number divided by itself is just going to be 1. To show that would be work though, so over here, cross out the 5 and the 10 and make it a 1 and a 2 over here. 1 and a 2. Then just cross out the B's, and then say equals. And then you have left on top, you have.
But you would add that.
No, it's all multiplication. You use that 1 times 8 times 1, which is 1/2. Actually, this is A divided by 2, because 1 times A times 1 is A. So you don't need the 1. Yeah, 1 times A times A is
Oh,
A.
yeah.
So this, and then 2. So that's A divided by 2.
And that's the final answer, right?
That's your final answer. So start with the 5 and the 10. And think of that like a little fraction. You simplify 5 and 10. 1 and 2. And then, look on the top, are there any A's on the bottom to cancel? Are there any B's? So they cancel and they're gone, right? So what's left? An A on the top. Yep, there's still an A, and then a 2 on the bottom. Yeah, because if you showed your work here, you cross out the 5 and cross out the 10 and make it 1 and 2. Because the 5 and the 10 become this. Cross, yeah, so that becomes 1 right there. So then it's like 1 times A times 1, or simply A. So you don't even need the 1 in front of it. Just becomes A. And then on the bottom it's just 2. Yes, that's your answer.
I'm not sure about that one, but I'm pretty
The
sure.
third one?
Yeah. Because those are both things, just the not, but.
Yeah, but where is the Z?
On
Z,
the bottom.
it's on the bottom, so you gotta show it on the bottom.
That is, that's probably just a 6. What do you mean 6?
I put the X squared, takes it to X's.
It's X times X. And this bottom is X times X. So they, each of those cancel one another out. It's all multiplication. The 2 just refers to how many times you multiply. So then the X squared and X squared go away. Yeah. Then you just have. Is that what it is? It's a third. It's 3 over 1. Yeah, plus 3. Here you don't have to have the 1 in front of the other. And you don't have to have the 1 in front of the Z, just so you know you won't be singing like that all the time. How are we doing now? Yep. Which one, the one on the bottom or top? Top? So look at the 27 and the 9 first. Can you simplify 27 and 9? What does it become? Well, what number goes into both 27 and 9?
Hey, it's changing colors.
3. How many times? For each number.
Huh?
Right. Hmm? I want to just do a multiplication table. You have one? You have one. Look at it. Look at the 27 line and 3 times 9 is 27. Yeah. So can you simplify 3 and 9? 3 and 9. 1 and 3. Okay. Now you have X squared and X squared. Those are the same, aren't they? So things that are the same, exactly the same, you just cancel each other out. Because whatever number you put in for X, if you square it, you get the same answer top and bottom, so you get the same number.
So the computer should choose answers.
What?
I got that because we're lazy.
The 2 and 2,
Oh, yeah.
yeah,
I was like,
then you go 1 over z.
I was
Correct.
hoping that we didn't have to do it, but I wasn't sure because I knew about maybe, now we have 3 computers
All right.
and then 40.
I'm not gonna stop. 48 CD. Over 6 AC. So try to do your work within here with crossing out and canceling. And trick, don't forget 48 and 6 being even numbers, you can just cut them in half to slowly work your way down. Half of 48 is how much? 24, and half of 6 is? 3. So now you can look at 24 and 3 and ask yourself if that can be simplified. Keep working forward like that. Get those other 3 done.
Yeah.
Yes, you. Oh, you're on the, oh, you're gone. Oh, maybe you can call them if you're ready. And then m over 3. Okay, so m squared and m is like, that's like 12 times m. This is like 12 times m times m. So one of the m's cancels. So that 2 cancels this. And then we have not 1 thing, but 6 goes in here, 3 times 6 goes in here. Right, yeah, so you might need to mentally remind yourself that squaring is, and then multiply by m. Don't get mixed up with that too. It's not part of multiplication.
What do we do when we get to here?
Well, okay, so that's like 2 times m times m
Yeah.
over 3 times m. No fraction mark, or no slashes either, all fraction marks. Okay? It's gonna get really complicated otherwise. So you think of 2m squared like this, 2 times m times m, and then 3 times m.
Yeah.
Then you can cancel one of those out.
Okay.
How are we doing over here? 4 pi over 3. Yeah, let me show you what this is here. Okay, so this is 8 pi times x. This is 6, right? Times x times x. That's what x squared is. So one of these this up, yeah, and then the same thing, right, so this x squared. And you see the x squared here is x times x. Up here, the n squared is n times n. So n multiplied by n at the top, and only one out here. So we still need to have that answer. So that squared doesn't come along, rather one of the n's does. So this is going to be 2 and 3. You following what I'm saying? So it's going to be 2n over 3. Right, Dawson.
Yeah.
What's 24 over 3?
That is 8. 8 over, no,
So then this becomes 8
8 over C. 8
d over 8. The c's canceled.
Yeah.
So I think we need to be looking at this as n times n for more than one of us, that's for sure. Then you can see that one of the n's will cancel. One will be left in your answer. 12 over 18 is going to be what?
6.
2,
6 over 9.
6 over 9,
Yeah, I was thinking
2 over 3. Here, if you call that x multiplied by x, then one of those goes. 8 over 6 is going to be 4 over 3. So it's 4 pi over 3x, because one of these is left over yet. Well, das ist alles.